Good day, madam. Hope you are doing good. I am Pavitran here along with Tasha, Kavinisha and Ahmed. So today we have chosen matrices as our topic and we are gonna explain how it's applied in our daily life. So first of all, I would like to talk about the definitions of matrices. A matrix is a rectangular array of numbers arranged in rows and columns. Matrices are commonly used to represent data, perform mathematical operations, and solve systems of equations. Next, I'm going to talk about the characteristics of matrices. First of all is dimension. The dimensions of a matrix refers to its size, represented as the number of rows by the number of columns. For example, a matrix with 3 rows and 4 columns would have dimensions 3 times 4. Okay, next I'm going to talk about the elements. Elements, the number within a matrix are called elements. Each element occupies a specific position within the matrix identified by its rows and columns indices. Third is the types of matrices. There are 4 types of matrices. First of all is square matrix, a matrix with an equal numbers of rows and columns. Second is the rectangular matrices, a matrix with different numbers of rows and columns. Third is a row matrix, which there will be a matrix with only 1 row. And lastly will be the column matrix, a matrix with only 1 column. So next, the fourth will be the operations. Various operations can be performed on matrices, including additions, subtraction, multiplications, and division. These operations follow specific rules depending on the operation and the properties of matrices involved. Fifth one will be the transpose matrices. The transpose of a matrix is obtained by swapping its rows and columns. Identity matrix is a square matrix with ones on the main diagonal and zeros elsewhere. And next will be the inverse matrices. For square matrices, an inverse exists if the determinant is non-zero. The inverse matrix denoted as A-1 when multiplied by the original matrices yields the identity matrix. And lastly will be the determinant. Determinant is a scalar value that can be computed from the elements of a square matrix. It provides important information about the matrix, such as whether it is invertible. So next I would like the next person to further their examples which is applied in their real life.
The first example of the usage of matrices in real life is in forest management. Matrices are commonly used in forest management for various modeling purposes. The uses of matrices in this industry dates back to the mid-20th century. One of the earliest applications of it was in the development of matrix population models, which originated in the fields of population ecology. These models were adapted and applied to forest management in the 1960s and 1970s to analyze the dynamics of tree populations, including growth, mortality and regeneration. Here's one of the matrices models, and the name of it is Forest Planning and Harvest Schedule Models. Linear programming and optimization models in forest planning uses matrices to represent constraints, objectives, and decision variables related to timber harvesting, wildlife habitat, and conservation. These models help optimize forest management strategies while considering economic, ecological, and social factors.
The next example is matrices are used in social networking analysis to study social structures and also social relationship. Social network analysis is an influential and now increasingly widespread methodological approach for analyzing the social world. We will be focusing on a particular type of metric called as relations matrix. Relations matrix. A relationship matrix is when instead of asking what value of an attribute a case has, we ask about the value of describing how a case relates. In this case, relationship and proximity. Multiple relations recorded for the same set of actors, basically in the same row, and each relation is a variable. Variable can also be defined at aggregate levels, so it basically follows the flow.
Assalamu alaikum warahmatullah. My name is Ahmed Mustafa and I will be presenting about the application of matrices within sports, especially football. So the collection of data actually revolutionized sports and team management. And by the meaning of collection of data, we actually refer to matrices. So a little backstory about matrices. It was actually found by Billie Jean, who applied the first type of matrices and statistics into baseball. So his idea was is to calculate the number of passes and football throws, and to create statistics from that, so he can predict and improve his players and team performance in numbers, not in theory or in cultural coaching as we know. So the application of such matrices or statistic taking, we can see it in the form below, which summarizes passes between three players, which are Cristiano, Messi and Zlatan. So the idea is that we can see the route of the passes, but in real life it's a bit hard for us as human beings to calculate these passes. So computers and matrices come to help. So computers track down the passes, and matrices calculate these passes. So it's a summary of the passes that have been done in a 90-minute match. So we can see a relationship between each player and player with the passes. So we can see that Messi to Messi is 0, because Messi cannot pass for himself. And then we have a relationship between Zlatan and Ronaldo passes, which is adds up to 8 to 2 passes, and so on and so forth. All these passes between each player and player are calculated to form the matrix form that we know now. So we can see that all the passes between these three players add up to 7 passes. So then, why are matrices used in sports? So we have 3 main points for their use. The first one is to help clarify a player's statistics and individual value. The second one, it helps to improve the predictions for the player, because we know, like, statistically how each player is performing, so we can predict how he will perform in the future after we train him more or give him more advice in his numbers. The third point is to form the football-oriented mechanisms that are now used, which are player matrices, pressure matrices, and others matrix-based analysis. In summary, matrices are the serious help that revolutionized sports as we see them today, and had played a major role to improve teams and players individually. Thank you.
Conclusion: matrices are a versatile mathematical structure that plays a crucial role in various fields of study and applications. They serve as a fundamental tool for organizing and manipulating data, representing transformations, and solving systems of equation. Matrices are characterized by their dimensions, types, elements, and support for various operations such as addition, multiplication, division, and also inversion. Understanding matrices and their properties is essentially for advancing in fields like linear algebra, numerical analysis, computer graphics, and more. So that's all.